Hello everyone, this is Harshvardhan and today I will be teaching you the topic exception handling in Java content. Okay, so the introduction to exceptions. So first, let me tell you about exception handling. It's an important feature of Java that allows programs to deal with errors during execution and maintain the normal flow of the program. So for example, let me tell you, during executing a program, slightly there are some situations where the program is not running by the code given. So for that situation, it would interrupt the flow of the program. And so Java provides a mechanism called exception handling, which allows programmers to create a diversion for such errors which help the programs to prevent crashes and work to the flow. So now, as you can see, like we imported Java lang, and then there's an object, then the throwable object, and then if there are errors, then it will stop the program. But if we put the exceptions, then it will go through the runtime exceptions. Like it will create a new path, and then same for there's another option known as other exceptions. Like after creating one path, it will go to the other. Okay. So now, so what is an exception? An exception is an event that occurs during the execution of a program, and it disrupts the normal flow of the instructions given to the program. So like for example, so in this it is given that exception, also known as arithmetic exception, here 10 is divided by 0, which is not allowed. So this program, it is wrong and it carries an exception. So what are the key characteristics of having an exception? So it occurs during the runtime, it interrupts the normal program execution, and it can be handled during exception handling mechanisms. So like as I told you, division by 0, it comes into an exception. It will disturb the flow of the program. Like also then, like if you put an invalid array index, then same thing will happen. The flow of the program would be not in the flow. Same goes for the file if it is not found, and accessing the null object reference. So let's go to an example. So example for without exception handling. So in this program, as you can see, um, the program, we have divided a number 10 by 0. Since division by 0 it's not allowed, so Java generates an arithmetic exception and the program terminates immediately. So as a result, the next statement will be executed as I told you the previous slide. So the result over here, it will show that there is an arithmetic exception which occurs. The program will get terminated, it would stop, and the remaining statements, it won't be executed. So why do we need the exception handling? Well, to avoid such terminations of programs, Java provides exception handling. It allows the program to handle runtime errors gracefully and continue executing the remaining instructions. So like as I told you, it interrupts error can interrupt the normal flow of a program, and having exception handling, the errors would be managed perfectly, like creating another path for the say instead of going to the main route. So what are the benefits of exception handling? Well, it prevents program crashes, then allows graceful error handling, maintains normal program flow, and improves reliability and robustness of application. So what will happen if we don't use exception handling? So the quite opposite of the benefits would occur, like the program would crash, the program won't work properly, then the remaining code it won't be executed, and then the person, the user may have poor user experience, and then there will be lots of debugging, and maintaining programs will be very much hard. So what types of exceptions are there in Java? So um, in Java, exceptions are broadly into two categories. Exceptions, in which they are checked during compilation, and unchecked exceptions, which are checked during program execution. Like as slides given, it checks during the compilation. It must be handled or declared. Like for example, IO exception and unchecked exception. It occurs during the program execution. It is normally caused by programming errors. For example, arithmetic exception, null pointer exception. The next slide, exception hierarchy. So all exceptions in Java are derived from a throwable class. As I explained you, the throwable class has two main subclasses, error and exception. Most runtime errors we deal with in programming belong to the runtime exception category. So as you can see, object, throwable, there's an error, exception, and runtime. So these are three throwable classes which get bifurcated. Throwable gets bifurcated into three sub classes. And then, so the keywords for exception handling, Java provides us several keywords for handling exception. These include try, catch, finally, throw, and throws. Each keyword plays a specific role in detecting and handling the exceptions. Each one of them has different um, role. So as you can see, try, it contains the code that may cause an exception. Catch, it handles the exception. The exception which you have put in try would be caught by the catch keyword during the exception. And then finally, it executes whether an exception occurs or not. Like if it, like after putting the exception in try, it will get catch, and after being caught, it will go to the finally, and finally will execute whether the exception is over there or not. And then throw, where we manually create an exception, and throws, where it declares the method signature. So as I told you, each carries a specific role. Now try block. So the try block contains the code that might generate an exception. As I told you, as an exception occurs inside the try block, Java immediately transfers control to the appropriate catch block. So here's the syntax. So now catch block. So the catch block is used to handle the exception. It contains the code that runs when an exception occurs, preventing the program from crashing. Like you throw a ball and someone catches it. So let's take the try as the ball and the catch as the one who caught the ball. So the try is the error, and the error has been caught. Like we can take it into that example. So here's the syntax. Then let's combine both of these try and catch example. So that in this example, take the division by 0. It happens inside the try block. Instead of terminating the program, the catch block handles the exception and prints the error message. The program then continues the execution. Finally block. So the finally block is executed whether on execution occurs or not. It is typically used for closing files, releasing resources, or performing cleanup operations. So here's the syntax. Multiple catch blocks. So so Java allows multiple catch blocks to handle different exceptions. So like one error, one exception, one try catch block, same to the other, and like multiple can be created. Throw keyword. So the throw keyword is used to manually generate an exception. Programmers use it when they want the explicitity trigger on an error under certain conditions. So this is the syntax. Here's the example for throw. So over here, if the age is less than 18, then the exception, like the exception will work, and we have created a manual exception into the program over here. Throws keyword. So the throws keyword is used in method declarations. It includes that a method might generate an exception and passes the responsibility of handling to the calling method. So here's the syntax. Okay, so here's the example. We took the example of a file reader. Okay, so the advantages of exception handling. So in exception handling improves the reliability and stability of programs. It prevents the abort termination, allows proper handling, and separates error handling code from the normal program logic. So the conclusion. To conclude, exception handling is a powerful feature in Java that helps manage runtime errors effectively. By using catch, try, and finally block, programmers can build more reliable and robust applications. Thank you.